am going to go ahead and get started just for the interest of your time. The first few slides, I've got some review and things like that. So it's not going to hurt anybody if they come in a couple minutes late anyway. I just wanted to welcome you today. We're having our third and final session of the Math Content and Strategies Developing Students Algebraic Thinking series through the Regional Autism Advisory Council. That's a lot of mouth words there. So thank you so much for coming today. Again, this is session 3 of 3, and today we're going to be focusing on explicit instruction or explicit guidance to students. I think explicit instruction is sometimes a little bit of a loaded term, so I'm going to use explicit guidance if I remember to do so. Um, but this is sort of part of our thinking about high quality math instruction and how we can use that to support all of our learners in many ways. Again, this series has been sponsored by the ALLOhio Literacy and Learning Science Project which is funded through the state of Ohio, and also from RAAC at the University of Cincinnati. And again, the questions were sort of looking at the sort of overarching thing is how can we leverage what we know about really good math teaching and learning and supporting our students not only in their math learning, but just in everything they might possibly need. Can we get them more language skills? Can we get them more logic skills? Can we get them more confident? Can we get them, just really believing in themselves more? So it's this idea that high quality instruction can actually support their math needs, and we hope it does, right? But it can actually go further, and it can support students' general learning needs and reinforce that they are, good learners too. So just as a quick review in sessions 1 and 2, session 1, we were focusing on different ways that we can represent math ideas. So representations can be sort of thought of as symbols. But when we looked at the CSA framework, which is where we go from concrete to semi-concrete to abstract representations, we get that idea of being able to take materials and move them around to help really understand the movement of numbers and how math works. And then recording that in a pictorial way themselves after the concrete experience, or being able to just look at a picture and understand some math ideas after they've had some of those concrete experiences. And then, of course, abstract is where we start to really get into the math symbolism that we associate with math. But beyond CSA, we can also think about things like, word problems that we can use to draw the kids into a situation that might be interesting to them so that they're more willing to engage with it. Or using words, either oral or written, to help explain something. Sometimes we even use gestures. Drawing pictures and models is sort of part of the CSA, acting it out or using physical modalities. And then things like, number lines, which are somewhat graphic, but can also be physical in nature. And so we talked in that session about things like manipulatives as ways to represent math ideas, but also how can we use our body or how can we talk? And that can really go across many areas of math. But it also, as you can imagine, helps tap into a lot of the other skills that could make students be more confident just in school in general. And then in session 2, we focused really most exclusively. Sorry, I have a ladybug in my house and it is flying around the light and it's distracting me. So sorry if I look up. We focused in session 2 on word problem structures that sort of, was representative of the idea that we can give students a name for something instead of just, it's not just word problems and there's 1,000 different kinds, but there's a limited number of them. Each type has a name. And then really just making sure that we don't overexpose them to, say, equal groups or array models and never really talk about other ways that we could structure problems. So this overarching way that, math can sometimes lean into sort of easy things instead of really, exploring the complexity of items. So, making sure, hi there. Nice to see you again. We're just getting into review time now, so we'll be back together to introduce selves in just a second. Um, so in session two, we were really just sort of using that problem solving structures. I know word problems can be a problem for a lot of kids and especially students who struggle with language skills, but making sure that they get the wide range of experiences with different types of problems so they're not surprised when they come to those high stakes tests or, just real life problems. And so that brings us to today, and I did want to take a minute to have everybody just, come in and say hello. And if you're new here today, then go ahead and use that left box as your prompt. Just give me your name and school and level and, a little bit of context for why you're here today, what brings you here. And if you're a returning person, feel free to include, anything that has occurred to you since some of the last sessions that we've had. So I'm going to go ahead and start with Rebecca, if that's okay.
Yeah, that's fine. Hi, I'm Rebecca. I am an intervention specialist at Cincinnati Christian. And since last time, I drafted up word problems that all had to do with school supplies so that I could use what I had in the classroom as um, the concrete thing. So it was like pencils, and I'd pull out my pencils. And
Okay.
we focused mostly on the addition and subtraction just because that's what my students are focusing on. But we did a few multiplication. But I tried really hard to mix up the types of problems. I don't know how well I did, but
Okay. So you weren't just doing all just adding or just all subtracting where they would know, oh, I'm just going to be adding or
no, they
subtracting
were
because that's what
mixed.
we're
And
doing
then
right now.
and I tried really hard to make it like one change, one put whole. But I don't think I did a very good job with that one. But I tried.
Well, how did they respond is really the test of things, right? Did they seem interested?
They did. They liked using the pencils and the actual objects. So.
Okay. Good. Good. Thank you. Sydney, you want to go next?
Hi, yeah, I'm Sydney. I work at the Heights Center of Excellence, and I teach middle school. And so I've been kind of did like a mixture of the first session and last session with what I was trying to do with one of my students, because she's doing word problems, kind of a mixture, addition, subtraction, multiplication, and division. And I've also been trying to use things just around the room while also trying to guide her away from the I had it in my head now. I can think of it. The words that help you, key terms or whatever we talked about last.
Keywords, yeah.
Yes, thank you. I'm like, why can't I think of what that's called? But I realized how much she like that is all she thinks about when she's reading a question. So I'm trying to guide her away from that. But yeah, using just actual objects around the room have really been helpful, even if it's not what's actually in the question, but saying like, hey, we're gonna pretend like this is that, or just
Okay.
drawing the picture on the board has been really helpful for the specific student I'm talking about.
Okay, great. And I put together a resource list. I think we've been doing that each time after the sessions. And I found an article. I wasn't sure if I still had it, but I'll include that in the resource list because it's freely available online. NCTM doesn't always give all their stuff away. So I found the article. It's called 13 Rules That Expire. So there are things that we might say to kids when they're younger in math class that later on becomes not true. And one of them relates to what you were just talking about there, Sydney, in terms of the key terms. Sometimes we give key terms to help them up front, and we have the best of intentions, but in the long run, it actually, makes it harder for them to actually do some of the other problems that they come with, multiplication and division down the line. So I hope you'll look for that one. It's a pretty quick read. It's pretty good. It's got other ones besides that one in there too, though. So it's I think a nice little article. Thank you so much. Um, I'm gonna try your name, Shakesa. How did I do?
You're close. Hi, everyone. I'm Shakisa Ogletree. I work for Cincinnati Public Schools.
Okay.
I'm in our Transition to Work program called the Workforce Academy, and I work with students that are 12 plus, but we still have some issues with math and how to apply it to real world, like paychecks and shopping and all that good stuff. And what brings me here is because I need more tools in my toolbox to help my little pumpkins. I mean, my little grown pumpkins. So that's what brings me here. And hi, Sadie.
Shakisa, can I just do a follow-up question? You said 12 plus. Does that mean 12th grade or 12 years plus?
um, they are students that have finished 12 years of school
Okay.
and elected to stay a year or two more.
Okay. So they're not 12-year-olds. They're more like 17-year-olds,
Yes.
18-year-olds, something like that.
Yes,
Okay.
but
All right.
still on that those foundational skills.
Okay.
So
All right.
majority of them, not all of them, but majority of them.
Okay, great. Thank you. And I'm going to ask a quick question to Rachel. Rachel, we're in the process of getting videos of the first two sessions. Is that correct? Will those be available?
Yeah, so I think within the group we could probably share the video, but as far as
Okay.
posting online, I just want to make sure I know people have been discussing their own situations. So if we do post it on the website, we'll make sure that any kind of personal details would be taken out.
Right. Okay. And we can also, for those of you that are new today, we've sent out resource packages, little emails after the first and second session. So that way you can have the PowerPoint and any resources that we included there. So we'll make sure you guys get those too. Lillian, would you like to say hello? I'm not sure. Lillian, if you're trying to talk, we can't hear you, but it looks like you might be muted. Okay. Lillian, we're going to come back to you if you're having some audio difficulties. Just pop on whenever you're ready, okay? Okay. All right, so let's go ahead and I'm going to have Sadie go ahead and just say hello real quick.
Hi, everybody. I'm Sadie Everett, and I'm the director of the Regional Autism Advisory Council at the University of Cincinnati. Excuse me, all of this warmth and I don't know, now things are flying through the air and now my allergies are acting up. So anyway, what I do with RAAC is I provide opportunities for people to come together and connect. And I also provide opportunities for training and professional development. So I teamed up with Lori and Rachel on this training series to bring these awesome math strategies out to the world, some of the world, and it's been a small but mighty group, and I really appreciate you all engaging and interacting. I've definitely learned something, and I appreciate you all taking the time to be here. Thanks.
And Rachel?
Hi, everyone. I'm Rachel Evans. I'm with the UC SDI Center working on this project and a couple others. So if you have any questions about ALLOhio or the modules, if we talk about those, you can always reach out to me.
Thank you. And I'm Lori Foote. I'm a faculty member at University of Cincinnati. I teach in the Research Methods Department, but I also have taught elementary and middle school math methods for about the last decade. And before that, I was actually third, fourth, and fifth grade elementary math teacher for, we'll just say a couple of decades. So, I met Sadie when I was working with Rachel at the SDI Center last year, and so we decided that kind of showcasing some of the ideas that are present in the ALLOhio modules might be helpful for the folks in this group. And so here we are today, and we've been having a good time. The format here is actually very just discussion based. So don't hesitate to unmute yourself and just pop on and say what you want to say. Don't, this is more discussion than a presentation. So I've got some stuff to share on my slides, and I'll try and get through as much as I can in our time, but I think the discussion is the real key to all of this. So I'm going to go ahead and get started from there. Kind of continuing on then with the idea of what algebraic thinking is, and I know we've talked about this the last few times, so I'm not going to beat a dead horse, but it's this idea that really thinking about algebra is all of the things that we're doing from kindergarten up through high school when we actually get into that formal algebra class. It's all of the things that have to do with developing how ideas about how math works. So it's not just how I solve this one problem, but how can I solve a type of problem or many types of problems? How do I write equations in a way that's sort of familiar to other people who are doing math? How do math properties work? How do numbers work within those properties? And then, in math education, we talk a lot about what's the standard way that we solve a problem. Using the equation and sort of algorithms, you might write things up and down and you add the numbers in columns. But we can also talk about alternative ways that we can solve problems that might make more sense to our students. So all of that is part of algebraic thinking. So it's this really rich progression of ideas that occur over a long period of time. And so where the student is in school is actually of less interest, particularly to this type of audience, because you're targeting the instruction for where your students are at this moment and where they are on that continuum. And so today we're actually talking a little bit about this idea of explicit guidance, or making those things that we want them to know very transparent. We're not hiding it from them. We're not hoping they guess it. We're not hoping they get it on their own, but we're actually being very explicit about making sure they understand the math content that we want them to learn. So the idea of high quality math instruction that relates to the topic of being explicit, I'm just going to organize this into 3 tips today that are subdivided into a couple things underneath it. When we think about being explicit, it's just the idea that I'm not hiding things. I'm really finding approaches to make my thinking and the ideas of math explicit. So we're going to first talk about how we can help students with key math terms. Math is like its own language. There's just no other way to say it. Sometimes it uses the language that we have in, just language arts. When I taught 3rd grade, we talked a lot about SOME sum and SUM sum, and how it sounds the same, but they're very different words. Sometimes we use the exact same word to have 2 different meanings. So math can be a little bit confusing. So making sure that our students actually know key math terms is one of the key strategies for being explicit with them. So one thing that I did many years ago was to develop a math word wall. Word walls were already popular in the language arts classroom, but I decided that using a math word wall would be helpful, and I did mine very similar to what you see on the screen there. I used a lot of visuals and a lot of arrows to point, much less intensive in terms of the language load. I got a lot of pushback actually from my district at the time, so I'm feeling very gratified now when I go out and I look around and I see that math word walls are all the rage. And not only are they math word walls, but they're how I conceptualize them, by having, you know, things have less writing on them, because the kids who really need math word walls the most are usually the ones that have the least amount of words already in their own toolbox. So I do think that having these visual word walls is extremely helpful for students. But I think not only do we want to teach the terms explicitly and we want to use those visuals, we want to let them use the words. When I'm working with my pre-service teachers, we talk a lot about vocabulary, and oftentimes they talk about how they're going to teach the word, but they don't talk about how they're going to require that the students also pick up that language and start using it. So really thinking about how can we get the kids to use the language of math too, because the more they use the words, the more they're going to own not only the words, but also the topic and the actions that go along with it. So some of the things you can do are to do some games. Um, One thing that I know I myself did in the past, I might have a series of word wall words, and because of limited space, I maybe would put some up for one unit and then take them down or put them on an anchor chart and then bring them back out when I came back to needing them. Um, but we would do some things like I'm thinking of a word wall word, and you could take just a few minutes once a week and go and say, I'm thinking of a word and it has to do with this, and give them some clues, and you'd have the student go up and point to it. They might say it. I saw recently some folks, they would actually turn off the lights. I had little fairy lights in my room, so I could have done this too, but use little laser pointers and everybody can point at the word on the wall, things like that. So they can practice the words that way, or they can whisper it to their neighbors to get them to use the words. You could also do something like, I'm thinking of two words that are on the board, and I see something that's similar about the two words. For example, I might say, I see the word equilateral and I see the word equation. And they both start with EQUI. And I know that they both have something to do with things being equal. An equilateral triangle has all equal sides. An equation has two sides that are equal to one another. So then I would maybe do an example, and then the students would, pick out some words from the word wall and tell me what they were seeing that was a relation between them. Sometimes, the relationships were a little bit superficial, but they were still continuing to practice those words and talk about their meaning. So I do have, a few additional ideas that I'll include in the resource list, but I'm kind of curious, do you guys have any ways that you like to practice terminology specifically to math, but it could really actually be something that you use someplace else, and now you're going like, oh, I could use that in math too. Any ideas you'd like to share with the group?
I don't necessarily do a word wall because all my students I teach 5 different maths, so it's not necessarily a word wall, but we review the words before we'll start a lesson, so it's more just kind of like a vocab review than a word wall. Um, or sometimes I'll just put it on like my smart board, depending on if it looks confusing or not with all the other lessons. But a lot of times I'll just do a review so they don't get confused and start overthinking it with all the other words that don't relate to what they're trying to focus on.
So you're kind of doing like a targeted review of just the words they're going to need for that day, is what it sounds like.
Yeah.
That seems really helpful. Else? I do know I would teach two groups of students a day, and so they would actually travel from my classroom to another classroom. We were in the third grade, we did that. So we had parents that would say, I need more stuff for at home. Plus the kids, when they go to do their homework, sometimes they wouldn't remember a word, and this was back before we Googled everything. So we did start using portable word walls. So the students would get basically the words that were on the wall, they would get to put into a specific notebook that they were allowed to take back and forth to school. There's always that chance that they're going to lose things, and that was a reality. But today we can actually use things like digital versions, so you can create one that is available online that parents could, open up. And I know there's some different websites that you can use for that. And I think I've got something, at least one example of that um, in the resource list. The other thing I've kind of got there, and it's grayed out a little bit, is a freebie, and it's a link. The Department of Education in Virginia has it's all math word wall terms, and this is an example of one right here. But they've got them all graphically, and they're organized by grade level. So you can literally just go in, find the ones you want, and print them, and then it's like you can just put it right up on your board. So it's very nice, because I know Pinterest sells them, but the Department of Education in Virginia is giving theirs away. So I'm going to give you that link as well. So, just having students, have that continuous opportunity to talk, review, have access to the meaning of in case they forget when they go to do a spiral review, things like that, is just really important for students having that explicit and repetitive type of instruction. Another thing that we included when we were writing up the ALLOhio modules was the idea that you can actually use some of the tactics that you might use in language arts and apply those to math key terms. So thinking about connected meanings. A quadrilateral has four sides, and this quad or quad runner type of vehicle has four wheels. So trying to use any connections that you have between words is really helpful. I know when you have students that are actually speaking Spanish, many of the words will be similar, and I think they call it cognates. But if you're aware that there's some language learning that's going on, and the student's own language would help support them learning the new language, certainly make connections between those if you are aware of it. The second one there is a think aloud. And I think after you've been a teacher for just a few years, you start just sort of narrating everything you do. And it's this idea that, when I'm thinking aloud, I am actually telling students what's going through my brain as I am going into a problem. I can do the same thing with vocabulary. So I'm not really sure what this word is, but if I was going to guess, I would start to look at this part of the word, or look at this part of the word, or look at it in the context of the sentence. I might look it up in a dictionary. I could use the glossary in my book. These things that we kind of do to help model how students can think through, wow, I don't really know that word, and I'm not sure how to figure out how to answer the problem because I don't know that word. Well, what are some things you could do to help yourself? So kind of using that think aloud strategy or narrating our mental processes is helpful for even vocabulary. And then the third one there is a little bit small, but it's using a graphic organizer. The one we've got there is a Frayer model. In the center, you can write the key term, and then at the top left, you've got the definition. On the top right, you've got characteristics. It's sort of like it's the opposite of synonyms, antonyms, kind of things. Examples. So in math, where are you going to see that word being used? So give an example of it. And then a non-example is frequently helpful. So, you wouldn't obviously want to do that with every single word, but if you have some words that students tend to struggle with year after year, that are really important words, you might actually want to invest the time in that. And that could actually go into their portable, if it was a paper-based portable word wall booklet. So those are a few ideas that we had. Does anybody have anything else they would like to share on the topic of vocabulary instruction in math?
I was gonna say, once I stopped talking earlier, a couple of my students have binders with just specific pages of if we're doing certain things, like their own personal word walls, like that they bring to lesson. Because a lot of times, like I said, like if there's so many things, like they can't figure out what they're actually supposed to focus on. So a couple of them have binders, and I'll tell them like get this one or get another one depending on what we're doing.
Okay, good. Yeah. And really just thinking about them, I think having what they need to make sure they can keep moving forward and not hit a wall, right?
Yeah, and just like like thinking aloud. Like I think aloud all the time when I'm teaching, and I'll start to tell my kids like if you while you're solving it, like tell me what you're doing. Like trying to make them also think aloud, because then it's a lot easier to catch where they're making mistakes, because they'll say it and it's like, "Oh, well that's not what you're supposed to be doing."
Yeah. Yeah. And I think even when they start to say things aloud, they realize, oh, wait, that doesn't make sense. And they don't realize it when it's just circling around in their head. But when they say it out loud, somehow it's different. So really, I think, if you have taught language arts and there's anything you can possibly use for both, double dip on it. So our second strategy that I had in mind, of course, this really aligns with, UDL, both of them do, in terms of really making the language clear, but we've got this new set of, we'll say, the letters and their symbols. So how can we help students to not be stymied by the actual symbols of math? So be explicit about it. Tell them what it means. And I think one thing that I really never considered when I was teaching was, once you know a word, you just know it. If you know the definition, you know it. And really, the definition is the beginning of knowing something, but a concept really deepens over time. So on the screen there, you've got a balance beam, and I like to use a balance beam to help really give sort of like a metaphor or analogy for an equation. So this side is equal to this side. And so you've got that equal sign, and that's sort of like the balance beam. And then what's on the left is the 15 plus 29, and that would all go in one pan. And then the 100 minus whatever you're going to put in that blank would go on the other pan. And to keep the whole balance beam equal, you have to make sure both sides are equal. And so you really using that balance beam image, and a lot of times I would actually box around both sides so it really became clear that that was the balance beam in the equation. Helps students not to make like common errors that I saw in the grade that I taught, which was they would, for example, if that first one was 15 plus 29 equals blank plus 100 or something, they would just fill in that blank with whatever was on the other side of the equation, and they would ignore the rest of it. But both sides of the equation are really important. And so that's such a preliminary skill before you get into something like the second line there, where you're going to be balancing equations. And that idea of balancing equations then really reflects back to what we've already talked about with making equations or making both sides equal. But then the at the bottom there, we've got 4 different levels of conceptual development. So students may come to you and have some sense of what it means to have an equation or for both sides to be equal. And so they may be at if we kind of look at that as a level 1, 2, 3, 4, they might be able to be at 3, but we want to really push as many kids as we can up to that 4th level where they really know the words. They can give a meaning for it. They can give examples for it, sort of like what we saw with the Freire model. They don't just have like this little thin knowledge of the word, but they really know it and own it. So sort of related to that, I've got a little activity for us. I'm going to drop a link in the chat. And I want you to go ahead and pull up that website. No, that is not the right one. Wait. Don't pull that up. Sorry. Sorry. I opened it myself. It's the Math Vault Glossary. And I think go all the way to the very top. You should see a definitive glossary of higher mathematical jargon. And I went as hard as I could think of. Mathematical jargon. So I wanted you to just sort of skim through this list. And I've got it on the screen too, in case you didn't want to pull it up. But there are probably words in there that you're like, oh yeah, I know that word. And then there's other words that you might be at a level 1. When I think about hand waving, I thought, okay, what does this have to do with math? I'm not sure. I'm at a level 1 there. When I think of elegance, I probably would think of like a standard algorithm as being a very elegant way that's very efficient and easy. Once you know how to do it, it's a very elegant way of solving a problem. So I just wanted to sort of share some of the words that I think would be hard for most people, and kind of just have you think about, what are some words that you have given to your students that you kind of had a sense that they would know it from a younger grade, and then kind of found out later that they just had a very bare, skimming the surface type of understanding of that word. Have you ever come across anything like that?
A lot of my kids don't know like what product, quotient, like that kind of stuff means, which is something that my students should know. And so, yeah, and I was thrown off when they didn't know it.
Mm-hmm. Mm-hmm. I also feel like there's a lot more emphasis these days on sort of hypothesizing in math. Like, if you do this, what do you think is going to happen? And then having them actually solve the problem and see if what they predicted happens, and then having to explain it. So words like hypothesize, explain, justify, those all come up in math a lot more than back in the olden days when I was in school. Conjectures. Um, I feel like they're words that are just, I think they would understand how to do it if an example is given, but it's really hard for them to know how to do it unless you practice it with them. But I think factor and product are a little bit like that too. It's interesting as I'm looking at this list again too, the idea of I've heard it or seen it, but I'm really not sure what it means. It's kind of amazing how we kind of go through our life and we hear a lot of things because the world is just filled with stuff, social media and all the YouTube videos and all these things. And I think I've heard that word, but I cannot even put any kind of context to it. Or maybe, you hear somebody talking about it, so you know about it in that one little context, but you really don't understand how it relates to other things. So last week, or we were also talking about like with multiplication when we're working with our students that we can tie it back to repeated addition. So any chance we have to take math ideas and link them to one another, sort of we don't want everything in like having to do with multiplication sort of clustered in this part of our brain and everything with addition clustered in this part of our brain, never to be connected. But this idea that when we have a really rich understanding of key terms and key ideas in math, they have relationships to each other. So it's not even really just words, it's how math ideas sort of link to each other too. So hopefully I haven't gotten too far deep into that little space there, but I really, when I saw that, it's called 4 levels of conceptual development. I thought, oh, that's really interesting because sometimes our students they already know some part of it, but we're actually pushing them deeper into knowing it. So along with equations, obviously the not equal is also possible. So we could take that balance beam and we can also think about how can we use that same analogy of a balance beam and now talk about inequalities. This side is greater than this side, or this side is lesser than this side. So we can actually continue to use our hands with the gestures. Many students will need physical opportunities. This is another example of bringing in concrete objects. So if you can get your hands on some of those little balance scales, kind of like we saw in that last slide or here, and the students can actually come to understand that when it's heavier, it pushes that side down. That's really helpful for tying then these inequalities. So I will actually take and write the inequality and put it at an angle. Sometimes I'll put it on a sentence strip and I'll actually take that sentence strip and tilt it to help indicate this side is heavier because this side is the greater side. And so what can we put on this side? And this would still work, where this side's going to stay heavier than this side. So just really helping students to understand inequalities involves, this idea of we can use this symbol or this balance and then use it to show this side's heavier or this side's heavier. And then we're really moving them into understanding this symbol. And the side that's open is always the heavier side. So we read it left to right. And so this side, 65 plus 89, is greater than whatever we put into this box. And what we put in that box could be one single number or it could be an expression. So on the left, we've got 65 plus 89, but on the right, we could put 65 plus 88. We could put 64 plus 87. We can put a lot of things in there to keep that relationship the same. So the left side just has to stay heavier. And then, of course, showing that the opposite way is really important so that this side is the heavier side, but we have to read from left to right. So 35 plus 80 is less than whatever is in this box. So we have some choices about what we're going to put in this box. And, is there a pattern for what could go in that box would be where we're going with algebraic thinking. So not only could we put something that's one more than the left side, we could put anything from that number on upward. And we could actually show those types of things on a number line. Everything to the right would work. So really developing students' full understanding of math concepts. If they have some preliminary knowledge, already, the idea of developing their algebraic thinking is we want to make sure that we're pushing them along that continuum and continuing to deepen their understanding. So while they might do things like this in the third grade where they just have one thing to fill in on the in the equation blank, you might have them fill it in 5 or 10 times when they're getting to those upper elementary grades, because there's many, many things that will fit into these blanks, which is part of what they are learning about inequality. So not just that one side's heavier or lighter than the other, but that there's many possible answers. Any thoughts or feedback on that idea? I feel like I'm talking too much tonight. Just reflecting on your own practices. Okay, we'll keep moving on. All right, as the students are moving from those third and fourth grade symbols, they get introduced to new symbols in middle grade. So it's really important to be explicit with them about these shifts. Sometimes we forget they haven't always known that the times symbol is going to become a dot when you get into the upper grades, or that you're going to put a number right next to parentheses, but you should just know that that's multiplication. Like, if they don't know that, then we just need to make sure we keep reminding them. So we can put things like this on our word wall. We can talk about it in our think alouds to make sure that, as we're going through problems, we can, oh, I don't see a time symbol here, but I know they're hiding it from me because they know that this could be tricky for students and they're always trying to trick me when I take tests or whatever. So just going through that modeling process with them aloud with any of these. So in the top left there, you've got this idea that multiplication can be shown in a variety of ways. Once you get past about sixth grade, you start seeing those variety of ways, including, using variables. Division symbols, I can remember personally being very confused about why is my teacher writing fractions and calling it division. I did not understand that link between fractions and divisions when I was in about the sixth grade. So if somebody had actually just said, oh, I know in fourth grade you wrote it with this little dot with the, dot line dot symbol, but now we're going to actually be writing it this way, and we would read it 6 divided by 3 equals m, and just say it out loud. So we're not just pointing to it and say solve it, we're actually reading it like a sentence would be. And just being explicit about, now we used to write it that way, but now that we're getting older, we're getting another way of writing things. And sometimes you can even have an expression on top of that fraction bar, as you see in the second example there. A lot of times we do talk about coefficients. A lot of times we talk about coefficients like we see there with 2n. We talk about the 2 or the 3 or the 4 that comes before the n, but we don't talk about the invisible 1 that is in front of every other letter that's just by itself. If a variable doesn't have any number in front of it, that means there's just one n. So n plus 7 plus n really means I've got one n plus I've got another n or two n's. So just being really explicit about saying things that you think they might know, but just making sure that they do. Or saying, hey, how come that's true? And having them explain it to you. And then the fourth box that's there with the 2x and then the x squared, I think the idea that I would want to reinforce there is sometimes there are things that we've done it so many times over the years in our own math progress that we forget that those two look similar to other folks, especially when they're learning it. And so actually putting them side by side and saying like, you might get confused about this. Let's go over what this means. So 2x is when you've got two groups that have x in it. But when you say x squared, that's actually not adding the two x's together. It's multiplying it like the area on a garden, and then give some examples of that. So actually taking things that you can see that your students are getting confused and deal with them directly and say, I can see people are doing this, but really what they mean is this. So let's just review how these are different from one another and really compare and contrast those, which again, we're stealing from the language arts folks because we're going to do that compare and contrast even in math. And one thing that I do have that I'll be sharing with you in the resource list is a video where a gentleman goes through quite a few of these and talks about these. So I think it's helpful to actually watch that video. We won't watch the whole thing. I think it goes for a few minutes, but that's one of my favorite videos. And actually that series is a really good one. So I recommend highly that you look at that one. Any thoughts, feedback, things you've seen that your students get confused about?
I just took a screenshot of every one of those little boxes because I was get like kind of getting into it with one of my kids today in math class because she was like, "That's not what that means," and I'm like, "Oh my gosh, how can I explain this?" And now I'm showing this to her tomorrow.
Don't you love serendipity? Here it is. Well, and it's funny because it's almost as if we do actually learn these things so well that we forget we ever got confused about them ourselves. So actually going back and thinking about them like students, you go, oh, yeah, that's true. That's kind of confusing, isn't it?
They've started introducing the two different symbols for division, not the like line, but like the little, I don't know. They call it a house. I don't know. I don't know
That's
what
what I call it.
it. And that one of my students so confused. He's like, I don't understand. And I was like, what part of it's confusing? He's like, I don't know. And I was like, I don't know. You put one on one side and one in the, I was like, I don't know how to explain it.
Yeah. Yeah.
We
It's almost
figured
like,
it out. He's a little less confused, so it's
yeah. Okay, good. Yeah.
we've worked through it. We've done
You
enough
know,
practice problems that he's like thinks I think he gets it. But I was like,
but
I don't know. I don't know how to.
yeah. When you put the problems with the house, you have to read it from the inside to the outside to make it match up to the other one, right?
Yeah, yeah. And but the fourth grade was saying that when she wrote it like that last year, all the third grade kids like were like, we've never seen this before. So the third grade teacher I work with is trying really hard to prepare them this year, so then
Okay.
less confused for fourth grade. So she
Got it.
didn't even introduce the like the two dot symbol. She just went straight into the little house. And so I think it was that plus we've never seen division before. It just really confused this little kid.
Right.
He's getting
But
better. He's got it.
yeah, and I think, the thinking aloud slash modeling that we do when we say, okay, 6 goes in the inside, and we're going to say 6 divided by three, and actually reading it as we're writing it or having them translate it from one to another and just having that practice of, writing it both ways or saying it out loud. I think all of those things are just helpful for them to hear it. But I think the other thing, and I was just teaching about division the other day with my students in the middle school math class that it's like fourth and fifth grade. But we were talking about when we do like the house symbol, people will say three goes into six. And it's like that doesn't really match up to the multiplication language that we learned, which was taking six and organizing it into three groups. So if you say it the way we say with multiplication, I do feel like my students, a sample of, 20 years, they understood it better if I didn't use goes into.
I definitely used goes into with him, and he looked at me like I had two heads. He was so confused. He was like, "What?
What does that mean?"
Like, what are you
Yeah.
talking about?"
Yeah, definitely try it with the other way and just see if he responds to it. If you go back and you say, I've got 10 counters, I'm going to organize it into five groups. This is how I would write this with the little house, 10 organized into five groups.
Yeah.
How many will go into each group goes on the roof of the house. See if he responds to that because I would
I
be
think he
interested.
will because he's starting to get it, but
Okay. Okay. Charkisa, I don't know what kind of problems you see with your students. What kind of things are they working on?
Oh my gosh. I kind of left my students aside and I started thinking about my grandchildren. I have
Okay.
a seventh grader,
Okay.
and like the multiplication being shown in different formats is like banging my head on the wall. Like, how many times can I show this to him? And
Yeah.
then my granddaughter, she's in the second grade,
Okay.
and I'm just amazed that they're getting introduced to symbols and how it's confusing to her. So I'm listening to you and Rebecca talking about the house and watching, like I wrote the note, watch the language you use, like goes into versus how to group them. And I think all of that matters. So I pushed my kids to the side and thought about like what's going on in my household, what I deal with every night. So I'm sorry.
No, that's perfectly fine. Any math talk is welcome here.
That's where my
Yeah,
real struggle is at home.
well, and that's the other thing. Like, as parents, grandparents, the teacher's saying it one way at school, we're saying it another way, and they're like, "That's not my teacher did it." So having that communication piece when we were talking about like the word wall, even sample problems for this is how we're doing it in school, so you can see what we're doing. And how I would explain it to students even and have it written out in words. Sometimes just things like that are so helpful for helping to get the help we want from at home so that you're not having all those tears. So I'm very sympathetic to that. um Yeah, I would, like I said, there's a video with this, and he goes into greater depth with each of these. So, if these are of interest, that video will pique your interest, and he's pretty squirrely, so he's kind of fun to watch. So, um, our third and final topic for tonight, or tip, is really just thinking about scaffolding. Some parts of math just they are complex, right? There's just going to be multi-steps. There's going to be things that are just hard because there seems to be some things that are very abbreviated or very hard to follow. So thinking about what our students struggle with so that we can be really explicit about what's going on, because when they do it and when they talk about it, then, like Sydney was saying, I think Sydney was saying, you can figure out what it is that they're doing in their head when they talk. So having them do the problems, have them talk about the problems gives us some insight into where they're having difficulties. And sometimes you're just going to come up with your own little scaffolding. So this is less about, really good tips that is part of high quality instruction. And this, I think, has more to do with the heart of modification and adaptation that you all as intervention specialists are probably super familiar with doing on a regular basis. But I just wanted to offer a few examples as, really thinking about complexity. So I want you to go ahead and just on a little scrap piece of paper, solve that problem for me. We're not going to have to share answers on the Google Drive today. And that is for a strategic reason. Okay, when you get your answer, give me a thumbs up. Thank you. Okay. Sydney, you ready? Yeah? Okay. I didn't want to rush you. All right. So you all might be able to anticipate what's coming here, but this is part of the PEMDAS, or please excuse my dear Aunt Sally, sort of, what are we going to say, drama? A little bit of drama. So I'm going to share this video. It's pretty quick. I might fast forward through a little bit of it, but she does give the answer to the question at the end, but you'll see why she uses this problem in just a second. Let me know if you cannot hear this though.
And give the answers to. What's to blame? The PEMDAS acronym. Stay with me and I'll tell you why. The internet, and actually broke the internet with millions, I'm talking about millions of views, all because of this huge PEMDAS debate. Which operation comes first? Some people were having arguments about these specific and particular math questions. So what is all this fuss about PEMDAS? Well, PEMDAS is the order of operations. So as you can see here by this diagram, you have what PEMDAS stands for. So you have parentheses, or we say brackets. Either one will do, it's okay. Sometimes they have these brackets and they have different shapes, but they serve the same purpose. And then you have exponents. So exponents is like you have a little 1 or a 2 or a 3 at the top, whatever number at the top here is an exponent. And then you have the common operations, which are the multiplication, the division, the addition, and then the subtraction. And then they have this acronym that they use for PEMDAS, which is to make it easier for the students to memorize what it means. And here's the acronym. Please excuse my dear Aunt Sally. This is where I have the problem. I have the problem with this because it doesn't show left to right, right? So people think that this is a hard and fast rule. So if you are doing a specific problem and the multiplication is first, you do the multiplication first. But if the division is first, they're interchangeable, right? So this is where the problem comes in. So it's not a hard and fast rule. So they think that the multiplication always precedes the division and that the addition always precedes the subtraction, right? But that is definitely not the case. The acronym, please excuse my dear Aunt Sally, it doesn't help. And you can hear the frustration in my voice. It doesn't help the students because when I'm teaching it, I always have to say to my students that you have to go from left to right. That's the first part. And then it's whichever comes first. Multiplication and division, whichever comes first. Addition or subtraction, whichever comes first. right? So if you keep that in mind, then all these other major viral math problems that we had in the past wouldn't have been such a huge debate. Take a look at this one. So if we go back to the original question that I had at the beginning, always remember the left to right. So 5 minus 2 is 3 plus 1 is 4, right? But if they're not using the left to right and they think that the addition is before the subtraction, they would do this first. And this is where the confusion comes in. So they would say 2 plus 1 is 3 first, and then 5 take away 3 is 2. That's where the mistake would be, because it's whichever comes first between addition and subtraction. So even though when you see PEMDAS, the addition is first before the subtraction, it's whichever comes first between those two specific operations. So it's 5 minus 2 first, which is the 3, then plus the 1, which will give you the 4. So let me do one of those viral questions and settle this. So parenthesis, right, is first. So you have 2 plus 2. So that is going to give us a 4, right? So then we have to go back to the left. This is where the problem lies. We go back to the left and then we say 8 divided by 2, which is, that would give us a 4. And then 4 times this 4, and it's multiplied because remember this would still be in the parenthesis here. So 4 times 4 would give us the 16. Now if we were to do it with the debate that was going on using the PEMDAS as a hard and fast rule, there's no discrepancy here, there's no dispute here. 2 plus 2 is 4. That's not where the argument lied, right? So 2 plus 2 is 4, so that's fine. But then what they would do here is follow this and say, okay, multiplication is first. And then they would say this 2 times this 4 would give it 8. And then they would say the 8 divided by this 8 would give us the 1. That's where the problem lied. Let me do it one more time without all the other green markers around it. Let's do that again, right? 2 plus 2 is 4. So like I said, there was no dispute there. The dispute came here. Multiplication was first. They didn't go back to the left. So they would say, okay, multiplication's first. So 2 times 4 would give us the 8. And then they would say the 8 divided by 8. Then they'll go to division. 8 divided by 8 will give us the 1. That's where it went wrong. So the answer is 16 because we are using the whichever comes first between these two specific operations. So I propose we get rid of the confusing acronym, please excuse my dear Aunt Sally, and let's do something like this so it'll make it easier for the students to remember. Put it up on the wall, put it around the classroom so that they'll be able to see, yes, you're spelling PEMDAS, but this is not a hard and fast rule. They're interchangeable, whichever one comes first. I believe that's what we should do. So please excuse my dear Aunt Sally. Yes, you're excused permanently.
And she kicks her out the door. So that somewhat lengthy description, I did capture that on the next screen here. Just to clarify, sometimes we give helpers. It's kind of like what we were talking about last time in terms of trying to give something to make it easier to remember. But then the rule here has gotten muddled. So it can be either multiply or divide as you're moving left or right. And then either add or subtract. You don't have to do the adding before the subtracting. So this idea that sometimes we have helpers that have a little bit of a limited usability, make sure they're really clear. This is a lot less, sort of friendly up front in terms of, PEMDAS. Please excuse my dear Aunt Sally is what I remember learning. But it's easy to miss some of this nuance, and to think that there is all this math drama out on the internet just blows my mind. So there are helpers that can help, but then may, not work down the line, and that's something to be aware of. And then there's helpers like this where they don't talk for themselves very easily, and so having sort of that more complex thing, we could again add this to the word wall. We can give this something that they can put in their notebooks to take with them to make sure that they don't make that mistake. I think another one that's things that I experienced when I was getting into the 6th and 7th grade, as we were talking about input and output boxes, how to translate from this y equals 4x, or here f of x equals 4x type of equation, and you're allowed to put whatever you want in as x and just figure out what comes out as the y or the f of x, and then starting to plot it. And you have a lot going on there because we've got this input and output box, and somehow that gets plugged into the rule or the equation at the top, and then from there you're somehow supposed to get dots that go onto an equation, and that can be a lot for kids. So instead of having some of the steps feel very hidden, we could actually go through and say, okay, our kids are having problems with this. Instead of having this type of table, could I do this kind of table? Will this help my students to be able to see exactly what's going on? So I'm taking this number, which is a 0. I'm allowed to choose whatever I want to be the x. And then I'm copying this equation down. And every time there's an x, I'm going to actually put that x that I chose into the equation. And I'm using red because red is for my x-axis. And then I calculate whatever the f of x would be, or the y. And that's going to be in green because that's going to go on the y-axis. And then I'm going to physically have another column that shows, okay, my x was 0, then my y was 1. I'm going to put 0 and 1. I'm going to use those same colors. And then when I come over to my table, I'm going to actually make this axis red, and I'm going to make this axis green, and I'm going to go over red and up green and put a dot. I'm going to go over red and up green and put a dot. And so it's taking something that's got a lot of hidden steps and sort of pulling it out until they don't need the scaffold anymore, and just thinking, okay, they're having trouble with this. What can we do just to get them to the point where they're like, oh, I see where the numbers are coming from, and they don't need it anymore. And then it's like Barbie dolls. Once you get past them, you don't need them anymore. So just thinking about, what do my students need to make sure they don't get stuck and that they can see all the steps or parts of the problem so that they can continue to get to the point where they can let stuff go. Okay. I'm going to pause there. Have you guys experienced anything where you're like, like this is not something I anticipated, but as I'm watching them do this, I'm realizing that there's this mistake that keeps being made or something that keeps getting skipped. Have you had anything like that where you've kind of had to invent your own little hack for your students?
Nothing like necessarily inventing my own, but just looking at this, I was doing input output tables with my students today, but where it gives you all the input and then some of the output, and you have to figure out, they had to figure out what the rule was. And I didn't, and it just had the input and output, and then as we're going, they all kept saying different rules. I'm like, it's the same rule for everything. So then I added that third part in the middle, and that really helped them understand that it's the same thing for every single one.
Mm-hmm, mm-hmm,
For me, we were doing, at the beginning of the year, we were doing place value,
mm-hmm.
and one of my students was not grasping that. So we ended up, didn't make anything, but we ended up making her a place value chart that below had examples
Mm-hmm,
of
mm-hmm.
literally just like 100. And so now every time we do place value, I make her get out the chart, and it's just like in a little dry base sleeve so she can write on it and put them in the correct space. But
Yeah.
but then she can see it all.
Yes, and that's it. And eventually it'll click, or they'll get so used to it that they can just like create their own, or it's just like a little tiny thing that you're doing to bridge where they need. And just I think the thing that I'm thinking about in terms of this being explicit is kind of what you're talking about. It's just opening up or uncovering some part of it that she just can't get by herself, but will eventually, with enough of that practice, with that little tool that you gave her. That's awesome. My last little example here is when we go to solve one variable equations, you might have all these steps that they go through. And, the thing about complex processes is because they're complex, you're going to have to do a lot of examples, and really being methodical through each and every step is important. So in this particular process, they begin with having like items on the different sides of the equal sign. So 2x plus 3 equals 4x plus 7. You just need to get all of the x's on one side, right? But if it doesn't apply, as a math teacher, I might be like, skim right past and be like, oh, that one doesn't apply, and not really talk about it. Well, when it doesn't apply, I still need to know why. I need examples and I need non-examples. So going through every step, whether it's actually needed for this problem, and doing that think aloud where I'm saying, okay, that's the step, and that step is going to be used every single time. But if I don't need it, I should know why I don't need it, and really talk about, okay, in this problem, I don't need it because of this. Again, just reverting back to the idea that as people that have already been through math, we can kind of look at it and go like, oh, we don't need that. But by skipping a step, the students don't know when they're allowed to skip the step. Like, is the rule a rule or is it not the rule? Is it the rule this time or is it not the rule this time? Kind of like Sydney was just talking about. So really thinking about when we are using complex processes, are we using them consistently so that the students know how to use them fully and completely? And when we can skip a step, are we actually talking about why we can skip that step or why it doesn't apply to this particular problem? Because that's the thing with these complex types of problem, or in this, equation solving processes, is that it's trying to cover all possible equations. And so there's going to be things that don't apply to certain equations just because it's trying to be useful for all of them. So hopefully that makes sense. So that is all that I have for tonight. Again, Rachel or Sadie will be sending out resource lists in the email that follows up tonight's session. So we'll get you a copy of today's PDF. PowerPoint is a PDF, and it says word problem structures. Apparently I didn't change that from last time. I apologize. Everything that I've talked about tonight is going to be in the resource list. It's a little bit longer one than typical. I do have some digital things that I found that I thought were kind of good for helping to reinforce students. So all of that will be put into that follow-up email. So make sure you look for that. Again, what we've been talking about tonight is included in the ALLOhio Literacy and Learning ALG 1, 2, and 3 series. I hope that you are, taking a look at that and seeing that if that's something that would be of value to you. Those modules are absolutely free, and you can, once you complete them, you would be receiving a credit that you could use towards your professional development for your 5-year plan. So that's something that we just want to make sure that you know about and don't miss out on, and that will be included in the resource list as well. What you have on the screen there, and I think is already in the chat, is the survey related to tonight. We have an external evaluator that goes through and looks at the evaluations that you put in, just to make sure that we've provided you with a high quality professional development tonight in the closure to our series. So if you don't mind completing that survey for us, that would be awesome. And if you have any questions or anything that you'd like, to talk to me about, feel free to do that now too. Otherwise, I wanted to thank you on behalf of